This is okay. That I got. See the method of preparation, like the something we were studying on that day. I think we did not study. Here you see
No.
the short one we are going to study. Short one. This I think we study. You forgot. I think this is what the. This one is Q node. If you remember
No,
this
sir.
one.
This one we have not studied. No. Sir, only that volume numericals we have done. Sir, other these things we have not done.
Okay, no problem. No problem. So we are supposed to study the method of preparation, right? So,
Yes.
generally the hydrogen peroxide is prepared from the peroxide only. Okay, we prepare the like that barium peroxide we can take to prepare the H2O2. We take the barium peroxide. Can you tell me what is
Barium
the
peroxide.
what is the formula of barium peroxide?
Sir, BaO2
BaO2. How will be the structure of BaO2?
structure.
Hmm.
The structure can be linear. So two O is there and B is the central atom.
Draw here. Draw here. Hmm. Hmm. But in case of peroxide, if you are taking the peroxide, the linkage is like that, O dash O, so that its bonding become -1 -1. Then this structure is must be wrong because there is no
Sir, then if there is one barium atom and sir two oxygen atoms, sir, then how we can do the linkage?
that is what the structure is. Ba, here is ONO. This is so O bond O is there. So this is -1. This is -1. This is what the structure of barium peroxide.
Hmm.
Okay, let us move. Let us move. That how you are going to prepare the barium peroxide, hydrogen peroxide. The first method is by acidifying barium peroxide. So this we are using the barium peroxide. But what you are doing, you are acidifying with the H2SO4, right? So what will happen? Removing the excess water by evaporation under the reduced pressure, given hydrogen peroxide. So what will happen? This is the Ba. Here you will find that is BaSO4 is out. And what is left? Here the oxygen and here is the hydrogen. So it is forming what? H2O2, BaSO4 and
H2O2.
8H2. Water of crystallization will
H2
out.
remains as it is.
Okay. Next one you are having peroxo disulfate. That I also explained to you. Peroxo disulfate. What formula was there? H2S2O8. This is what the formula. You can see the number of oxygen 3 to 5, 538, H2S2O8. How we prepare? If we are having the HSO4, this is the HSO4 persulfate that is called. So sulfate, I know hydrogen sulfate, it is giving what it is giving on electrolysis. It is giving the peroxo disulfate. Can you draw the structure of this one? H2S2O8.
Sir, I'm trying. Sir, this will have the peroxide linkage.
Yes, 100%. Where you can draw here. What is the
Sir, in
compound?
peroxide linkage only, sir, only two oxygen should have bond or all the oxygen should have same bond?
No, this will be the oxygen will be there like that. The bond will be because the already the word is using peroxo disulfate. So disulfate means two SO4 groups should be there. The last class I told you the what is the sulfur valency? Sulfur valency, it can be 2,
Sulfur
it can
valency
be
is
4,
2.
it can be 6. If you are talking about 2, you can find H2S. If you are talking about 4, SF4. Okay. If you're talking about 6,
SF6.
6 means that is it can be the
That will be expanded octet.
expanded octet, na? So it can go in SO3. This is SO3. SO3. This is the 6. Valency is 6. Now, if I will say, the okay, tell me the structure of SF4. SF4.
Sir, SF4, so should be this one, sir, the square planar.
No, this is the seesaw shape. Seesaw shape.
Sir, how to know that which compound will have which type of structure?
That we already studied. VSEPR theory. See, sulfur is having the 6 valence electron. Out of 6, 4 is used in the bond formation.
12
And
lone pair.
1 lone pair. So total pair become how many? 5. 5 means trigonal bipyramidal. So trigonal bipyramidal S. Here is the F. This is the F. Here is the F. This is the F. And lone pair is here. So what is the shape is? Seesaw shape.
So trigonal bipyramidal means it should look like this.
So dear, geometry is trigonal bipyramidal, na? Lone pair electron do not participate in bond formation. Yeah. This is the seesaw shape only. Seesaw shape. Shape is what? Distribution of bond pair. Geometry is what? Distribution of electron pair. That is bond pair and lone pair. Lone pair electron do not participate in bond. So this will not do anything. So it will be like that. And what the structure, resulting structure is there? This is structure is seesaw shape. Getting?
Getting.
What about the H2S, shape of H2S?
Sir, H2S.
H2S,
Sulfur has 2, 4, 6. So,
H2.
sir, here it will be 2 electrons. So, that means, sir, all will be bond pair. So, that can be linear only.
So no, concept, why you are missing the concept? How can you say the linear? Because the here how many electrons are there? Oxygen, sulfur, selenium, tellurium, polonium. How many valence electron are there? 6 electron are there. Yes or no? Group 16 element, that is 6 valence electron. So if it is having 6 valence electron, how many bond pair? 2 hydrogen atom means 2 electron used in the bond formation. So out of 6 electron, two electron used. How many left?
4.
4 left. 4 left. Yes or no?
Yes.
2 electron used. So 2 bond pair. How many lone pair?
2 lone pair.
2 lone pair. So 2 bond pair, 2 lone pair. Total pair is going to be 4 pair. Yes or no?
So 2 electron means 1 bond pair will be there. No, sir. 2 bond pair.
2 bond pair. One electron of hydrogen, 1 electron of the sulfur. That is 1 pair. Just you need to count out the bond. That's it. Okay. So 2 bond it is forming means 2 bond pair, and there is 4 electron means 2 lone pair. So what is total how many? Which 2? 4 electron pair. Distribution. What is distribution?
Sir, this thing I don't remember, sir. I think I forgot.
Yeah. How can you say? 2 pair means linear. 2 pair means linear. 3 pair means?
The 3 will be
planar. Trigonal
planar.
planar.
Trigonal planar.
4 pair. 4 pair.
Trigonal bipyramidal.
No, tetrahedral. 5 pair.
Tetrahedral.
5 pair.
5 will be trigonal bipyramidal.
Bipyramidal. Very good. 6 pair. Octahedral.
6 pair octahedral.
Okay. So 4 pair is tetrahedral. So tetrahedral, how you will draw? Oxygen. So 1 lone pair here, 1 lone pair here, 2 bond pair, hydrogen, hydrogen. What is shape? Bent shape. Getting? So whatever the molecule are there, H2O, H2S, H2SE, H2TE, this is all H2TE, H2PO. This all are shape is what is there? Bent shape. This is bent shape. We study the VSEPR theory. Kindly, I think you visited na. That is why you disconnected with many of the topic. Okay, this is also one drawback. What the drawback? When we visit, so it create the problems. The concept. Okay, so I was asking that is you need to draw that one. What we are saying is structure of peroxo disulfate, but you did not draw. Yes, yeah, no. Peroxo disulfate. But this type of
So then
problem
there
they
will be two h2o4. So one
but that things will be asked, no, so no, that is the problem. That you have to this type of problem can be asked. See, sulfur maximum valency O, here is OH, double bond O, 22415, O, here is O, this is double bond O, here is that is OH, double bond O. Each sulfur is having 6 valency. Can you check here? 2, 3, 3 to 5, 1, 6. What is this one? Peroxide linkage. Getting? This is what H2S2O8. So, Sano here see, peroxo disulfate obtained by electrolytic oxidation of acidified sulfate solution at high current density on hydrolysis with hydrogen peroxide. So here two steps they have mentioned. What is there? HSO4 minus. Firstly, you are doing electrolysis peroxo disulfate. Again, hydrolysis you are doing, it will give the hydrogen peroxide. That's it. Okay. Now, another method is there. Here you see another method. What is there? In the laboratory, how we can, this method is now used for the laboratory preparation also. What is there? Potassium peroxo, this is there, peroxo disulfate, K2S2O8. If you are treating with the D2O, heavy water, this is what D2O is.
Sir, K2H2O structure will be?
K2, okay. Here you see S double bond O. This is OK, right? Double bond O. Here is O. This
Sir,
is
then it
O.
will be like this.
Like that
Sir, this
only.
is O S O K K O.
Yeah, absolutely correct. Absolutely correct. Actually, you are making the linear structure, na? But it is the shape is tetrahedral. Okay, this should be the shape is tetrahedral like that. See, shape is tetrahedral. That is also something there, but that not important. That much not important. When you study
So that
12th,
means this part should have been a bit tilt. So like this.
yeah. This one also. This one also. Why tetrahedral? Can you tell me why tetrahedral?
Sir, here there are one, two. So tetrahedral means
Four
four
sigma
bond
bond.
pairs are there. So that is
Four sigma bond. No, bond pair is 6. 4 sigma bond. 4 sigma bond. See, each
so
double bond
sigma
is
bonds are the
single bond. So each double bond is having 1 sigma, 1 pi. So here will be 1 sigma. 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 So total sigma bond is how many? 4. 4 pair means what? sp3.
Sir, in each half there is 4, but sir, overall there is 4, 4, 8 and 9.
No, per each sulfur atom we have to go, na. Each sulfur atom we have to go.
Sir, I thought you were asking for whole molecule.
No, this is also sp3. This is also sp3. So that is why tetrahedral. Any of the molecule like the h2p2o7, h2p2o7, this will come in the 12th. I'm just giving a little bit stress to your mind. That is why. This also the structure will be the tetrahedral only. That will come later on. That don't worry. Now,
Sir,
here you see.
sir, this the H2P2O7 structure will look like this, no? There will be.
But here peroxide is not there. Peroxide is not there.
Peroxide will not be there.
Why? One oxygen is getting missed now. One oxygen is getting lack now.
Then
That is why.
peroxide will not be able to form.
But H2P2O8 is having the peroxide linkage. H2P2O8. It is having peroxide.
H2P2O will be same thing.
Same
Instead
thing.
of S, we will be writing P.
Yeah, yes. Okay, maybe peroxide, you see O. Here is the OH. double bond O 2 to 4 1 5. Here 6. No. Wait. Peroxide will be there. We need to check. No, P2P. OH. But here 5.9 H2P2O7. That we need to check. Okay, leave that one. That is not there in the syllabus here right now. But next year you will study in a P block, group 15 element. That it will come there. So there we will study. Okay. Now it is killing the time. Here you see. So now if you see the industrial method, what is the industrial method here? Industrially, it is prepared by the R2 oxidation of 2-alkyl anthraquinone. 2-alkyl anthraquinone. So this is the alcohol is there, quinone, 2-ethyl anthraquinone. You are oxidizing this one. If you are oxidizing this one, it will give the H2O2. Okay. Here you will find this is the equation you will find here. 2-ethyl anthraquinone. It is there. No. Wait, we'll find out. This is not the anthraquinone. Wait, give me 1 minute. 2-ethyl anthra. This is the quinol, this one. This one. So here you see this is what is the anthraquinol is there, this portion, right? And the second position, this is ethyl is there. Now you are oxidizing with, so this is the quinone is giving 2-ethyl anthraquinone and it is releasing
Sir,
the
which
hydrogen.
one is ethyl? Sir, ethyl is which one?
This is this.
Not
Sir,
visible. Quinol is the.
This
sir,
one.
Quinol is the backbone.
This one. Total is the quinol. This is quinol. Then it is getting oxidation reaction. It is going to oxidize. So O2 and 2 hydrogen, this hydrogen. So H2O2 is out here and it is forming the quinone. This one is quinone. Getting?
Sir, I am taking this one in my copy, sir. Just 1 minute.
Otherwise, we can draw now. Can I draw there?
Yes.
See. Here. 1, 2, 3. This is there. Here is the ethyl. Okay. Here is the OH group is there. This is OH group is there. In the circle, you make the circle simple. Now you treat with the O2. So if you are treating with the O2.
This circle means benzene, na?
Benzene ring. So what will happen? See, this is the 3 are coming. Here, this is the O. This is the O. Here is the, this is like that, right? Now here in the center, there is no circle. And plus, what is there? H2O2. You can check here.
Sir, this is CH2, CH3, this one?
Here, this is the everywhere conjugation is there. So this we wrote now. This we wrote now. Here also you can make the circle. There is no problem. Because everywhere conjugation will be there. This is the hydrogen peroxide.
Okay.
Done.
Yes.
Now, see the physical properties that can you erase that is some screen, something is coming on your screen.
Yes, I can erase.
Little bit you erase, please. Not getting erased.
So getting.
Thank you. Thank you very much. So now see the physical properties. What is there? The first thing is colorless, right? Okay, it is almost colorless. Pale blue is there in the liquid state. Okay, what they are saying, the pure state is what they are almost colorless. Now, here you see physical properties they have given 9.4. Miscible with the water in all proportion and form the hydrated h2o h2o2.1 h2o. So water of crystallization is 1. Okay, melting point 221 Kelvin. A 30% solution of h2o2 marketed at 100 volume hydrogen peroxide. So 30% means what it is calling 100 volume. 100 volume. 30% means 100 volume. It means that 1 milliliter of 30% h2o2 solution will give 100 ml of the oxygen.
So this is the same thing like yesterday that that one also the 10 volume we did. That 1 liter will give 10 liter of oxygen. So here also 100 volume.
Here the 100 volume is 100 liter. What it will give? 100 liter.
1 liter will give 100 liter of oxygen. So sir, 1 ml will give 100 ml of oxygen.
Okay. So this is what is there. Commercially, what they are saying, commercially marketed sample is 10 volume. So commercially we are getting 10 volume, which means that is the sample contain 3% H2O2. The percentage we have done this one. This we have done. Right.
Yes,
so
sir.
1 liter H2O2 solution will give 10 liter of the oxygen at STP. That day we have done. So this portion I am not
Yes,
dealing.
sir.
Okay. Now the chemical properties is important one that we are dealing today. See the structure here. See the structure. It is having the non-planar structure. Can you see non-planar structure?
Yes.
That is here you see this is H, here is this is O, this is O, this is H. Okay, book like structure we are having. Okay, book like structure. Now what you are going to find, see this angle you see, this angle. If I am talking gas phase, so angle is 94.8 here you see. And if you are talking about solid phase, it is more. Dihedral angle. Dihedral
Hydrogen
angle.
peroxide exists as solid.
What?
Sir, I'm asking if hydrogen peroxide exists as solid.
Yes. At the certain temperature, I think below 20K, no, 20K. If you are cooling up to this one, it become in the solid.
Okay.
Okay. See here you see what is there. Dihedral angle. This is angle is called dihedral because this line also represent hydrogen 1. Upper line also represent the hydrogen 1. So the dihedral angle is how much they are saying. In the gas phase, 111.5. In the solid phase, 90.5. This is what the dihedral angle. The pen tab got hanged. So this angle you need to memorize, not much important. Chemical properties is very important. Chemical properties, right? So chemical properties we are going to study from this slide. You better study from this slide. See, first one, what if it is PBS is there? What is there? PBS, right? If you are taking PBS, so it will give PbSO4. So PBS is the what is -2. Here is 4 to the 8 plus 6. So it is oxidizes. Yes or no?
Yes, sir.
Fe2 plus to Fe3 plus oxidizes. Okay. SO3 2 minus SO4 2 minus. Here is how much there? 3 to the 6 minus 2 plus 4. Here is plus 6. Again oxidation. NO3 minus. NO2 minus to NO3 minus. This is again oxidation. Okay. Now, this is okay. It can act as a reducing agent also. If you are taking, these are the oxidizing agent. Here you see, oxidizing agent. This portion they are saying reducing agent. These are their for the reducing agent. Okay. So
Yes.
last day I told you that in H2O2 it is having -1. So if it can go, that is O -2, and it can also go O2 0. So if it is going 0 means loss of electron. Loss of electron,
Yes.
when you are going 0 means reduction, act as reduction, act as reducing agent. And if it is taking electron from other, act as oxidizing agent, right? So when the charge -1 to -2, here you see, when it is going -2, -1 to -2, so acting as an oxidizing agent because it is taking the electron. But if -1 to 0, -1 given the electron, so reducing agent. So HOCl is there, it is converting into Cl minus, reduces. Cl2 is there, Cl minus. I2 is there, I minus. Fe3 plus is there, Fe2 plus. So this act as an oxidizing as well as reducing agent. Come back here.
Yes.
So first chemical properties, let
Sir,
us.
previous slide, can you bring once more? Sir, previous one.
Okay. This
So just
point
1
you
minute.
should, this point you should understand, please. When it will act as an oxidizing agent, when it will act as reducing agent.
I2. I minus plus O plus O2. Cl2.
Something came on his screen.
Last section. 2x plus 2. Done.
Done. Wait now, 1 second. Can I share you the problems? Will you try the problems?
Yes.
Okay. So tomorrow morning, 8 to 9, you will study self-study, and then we will discuss the problem also. I am sharing the problem to you right now. That problems you check also. Have you taken the dinner?
No.
Sorry, it's getting late. Okay, wait, Sanoy. Wait, let me erase this
It's
one.
okay, sir. We can continue. So that is not.
Let me erase this one because okay. So now if you see this one, come back to here. So here is the chemical properties, na? Oxidizing action in acidic medium. Okay. So in acidic medium, if you are taking Fe2 plus, it is converting into Fe3. Do you know the balancing the equation or not? How it is
Yes.
2 is coming, how it is 2 is coming. Redox reaction I taught, I think. Yes. Balancing I taught in acidic medium. Here see, PBS is
Sir,
there.
we understood that total charge on right hand side should be equal to total charge on left hand side.
Okay, so here you see when the hydrogen
Sir,
peroxide -1 to it is going -2, taking the electron,
sir,
so
I was
acting as
saying, sir, I was saying that the total charge, positive charge on here in this equation, total positive charge on reactant side is equal to total positive charge on product side. Sir, because here is 2 into plus 2, here it is plus 4. Sir, 2 into plus 1, here it is plus 6. Sir, in the same thing, sir, if we check in the product side, so this is also, sir, 2 into plus 3 equal to plus 6.
Yeah, correct. So this is the oxidizing action in acidic medium. Second one, reducing action in acidic medium. So here MnO4 minus, here you see +7 is there. So it is converting into +2. So H2O2 reduces MnO4 minus to Mn2 plus. If you are talking about Cl it is converting into -1. Here is the +1 is there. +1 to -1. This is the reducing action. So when it is converting into its own oxidation state is what making? its own oxidation is increasing. So it acting as a
Reducing
increasing.
agent.
So a reducing agent. Oxidizing action in basic medium. You see the how it is acting as a basic medium. Fe2 plus Fe3 plus Mn2 plus MnO4 plus. So this is oxidizing agent. Reducing action in basic medium. So I2 is there 2I minus MnO4 minus MnO2. So different medium is there. So different product will form. There is nothing which we can do in spite of memorizing. Otherwise, you solve many of the problem, as many as problem you are going to solve, it will become the easy to you. So this is there. Now storage, you see, h2o2 decomposes slowly on the exposure to sunlight. That is why it is kept in what? How it is we are keeping? In the project, there you see, it is decomposing into water and O2. So in the presence of metal surface, traces of alkali present in the glass container, the above reaction, how the above reaction is catalyzed. It is therefore stored in wax lined glass. Where you are storing? Wax lined glass. Otherwise, if you are not storing in that one, so it will convert it to what? H2O plus O2. Another is there,
Okay.
plastic vessel in dark. Urea can be added as a stabilizer. What you are using as a stabilizer? Not for
Urea.
not to become is urea. It is kept away from the dust because dust can induce the explosive decomposition of the compound. So dust also. Now usage you see. What are the uses? It is having the large number of the uses are there. What is there? Hair bleach. You are using where? It is used in the daily life as a hair bleach. Second one, mild disinfectant means floor cleaning. As an antiseptic, it is sold in the market as a perhydrol. How it is being sold? Perhydrol. Keep in mind, if you want to purchase in the market, you will not find this in the form of the hydrogen peroxide. What you will find? Perhydrol.
Right.
Okay. It is used in the manufacturers chemical like the sodium perborate. What is there? Sodium perborate. Yeah, percarbonate, which is used in the high quality detergent. Because you see H2O2 na, H2O2, it convert into H2O plus it gives the nascent oxygen also. So this nascent oxygen is highly reactive. It acts as a what? That is the detergent. It acts as a detergent. No, detergent. Next one you see, it is used in the synthesis of hydroquinone. Okay. So it is also you hydroquinone is the medicine. Hydroquinone is the medicine. Okay. Quinone is the medicine. This is used. Tartaric acid. It is also used in preparation of tartaric acid, certain food products, and for pharmaceutical. Cephalosporin is there. One chemical is there. Cephalosporin. It is the medicine. It is being used in that. It is employed in the industries as a bleaching agent for textile, paper pulp, leather, oil, etc. So there also it is being used. Last one you see. Nowadays, it is also used in the environmental green chemistry. For example, in pollution control treatment of the domestic and industrial effluent, oxidation of cyanides, restoration of aerobic condition, sewage waste. So this is what where you are using in the sewage treatment. Also H2O2 is being used. Now, tomorrow we will study the heavy water, and then this chapter heavy water. After that, this chapter will be over. Okay. After this chapter, what you are going to study? That also you let me know.
Sir, I will let you know today night only.
Okay, please tell me. According to that syllabus, you will go na Akash only na.
No, sir, that mock test syllabus is sent you, na that one.
Okay, I will check that one. I will check also. You can also check. Otherwise, I must be having. There is no problem, right?
Mm.
Okay, so you go and take the dinner. We'll connect tomorrow 9 a.m. Right?
Yes.
Okay, okay. Bye, 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 bye. Take care.
Yes. Good night.